Hey everyone, it's Joe Lyons here in Dallas, Texas. We're currently melting. It's summer's hit. Jackie, how are things with you?
It's great here in Copenhagen, Denmark. And again, we are, I'd almost call it a heat wave, but it's not. And to you, this type of heat is probably almost laughable. But yeah,
Right.
to us, it is really, it's nice.
Yeah.
Let's put
Awesome.
it like that.
I can't imagine like when you start wearing shorts and short sleeve shirts compared to with me, I'm still like probably wearing a long sleeve coat or something. But yeah. So Jackie's in Denmark where it's a bit chillier.
Yeah, one of the things is that we have central heating, right? We don't have any type of cooling in our houses.
Yeah.
So when it actually gets hot,
Yeah.
we kind of suffer.
Right. Yes.
But again, we don't have any issues when it's cold.
Yeah.
Yeah.
Cool. All right. So today we do have an image that we're sharing. So if you're listening, we'll still talk through it. And this was from that service automation book, The Future of Work, Future of Employment, I think, that I read. And it was it's the graph is actually from HFS, and I can't remember what HFS stands for, but it's a research company that works in automation, in RPA, and those kind of things. And the image that we're doing is basically trying to break out the continuum, because it really is, it's not a black and white, the difference between robotics process automation and then true AI stuff. Is there anything you want to start off with here, Jackie, as far as?
I'd say most of what people with AutoHotkey is used to is more probably the leftmost trigger-based stuff.
Yeah.
Because of the hotkeys and the focus on that at the beginning. So yeah.
And that's an excellent point to start. And also, which I'm not sure why they didn't include it here, but when I start talking to this and I explain to people, I work. Someone actually asked me the day about their husband has a job where they were trying to scan these images, but the receipt or the image, the image might be in different spots of what they're doing. And I said, yeah, that's much more of an AI thing, and I don't currently work in that area, but I know stuff that's in there. And I was trying to say, look, and I work in RPA, and in RPA, you can think of it as really assisted and unassisted. And in the assisted part, that's much more where I start thinking about AutoHotkey stuff, is that it's very logical, very rules-based, and more importantly, what you alluded to earlier is trigger-based, right? Like I have a human generally starts the script, does something to start it to take off and do something.
Yeah, that's at least one way to put trigger-based stuff, right? It can be a hotkey, it can be the press of a button, it can be a scheduled Windows job. Yeah.
Right. But the fact that it's waiting for something, and I think it's a good point, time-wise or a person or something to trigger it. Once it happens, then there is some sort of logic that we have already basically documented. Maybe that's not the right way to phrase it, but broken it down to say, here is a process you're going to follow now that you start.
Yeah.
And then it might use some if-then logic or something like that to do a couple different things, based on it. But again, it's triggered off of, what we're doing. And you can be watching a folder too, or a website, and this and that, right? It's seeing that stuff.
Yeah, it's pretty not simple, but if you look around, even a language like AutoHotkey has quite a few examples of most of these things. Someone at some point, because how many years has 10 years or more? Was it 2004? Maybe 15 years for AutoHotkey? Does that sound about right?
Sounds about right, yeah.
Yeah. So of course, people have actually come in and had these needs and has made different types of functions. And if you ask or look around, someone will have probably the best implementation they can point you to. So depending if you wanted to run on a schedule, run when something happens in the folder, when you receive an email, whatever it might be. Yeah, it's great to have all these trigger functions lying around.
Yeah, agreed. The other thing, which is mentioned in the graph at the very bottom, talks about, hey, the side on the left, the side we're describing with RPA or desktop automation, you have very structured, data, and it's basically required because you're writing a program that's going to do X, Y, and Z once I say go do that, right? And like I said, maybe there's a little bit of logic in there, but it's very clear on what the process is going to be. On the other side, the AI side, is where it says unstructured without patterns. And Jackie and I were chatting a little offline of like, yeah, I think that's a bit of an overstatement because it's just that the patterns aren't as clear, right? That they take I don't want to say a higher life form because that's not the right term, but they take more analysis. Is that the right way to say it? To find the pattern?
That's probably a good way to put it, right? We kind of don't tend to think that faces has patterns per se, but of course they do. And we start learning as children quite quickly, almost inherited, how to recognize different faces. And it's the same with, maybe I'm quite good at looking at Danish faces, and might miss something from someone from Hawaii or something, where others from Hawaii would much easier see the difference in people's faces there.
Let me jump in here because I know I want you to talk to it because you're the one that knows this stuff. We've had conversations in the past discussing autonomous vehicles and the ability to distinguish a piece of paper while you're driving on the highway, a piece of paper floating across it versus it being a dog or a baby, right? Yeah. And that capability is highly, highly advanced, right?
Yeah. And I've still not recently, at least, heard anybody that has really solved that because, like, I know Tesla and a few others are focusing heavily on computer vision, where it's the same as we see, teaching the computer or letting it learn how to interpret things the same way that we do, whereas others has shifted more over to like LiDAR and stuff, where you send out an enormous amount of laser beams to kind of structure the world around you. But the issue is that if a laser beam hits something that reflects it back, like a plastic bag filled with air blowing over the highway, it sees it as something solid, something big, something that has mass. Whereas if we wouldn't see it as this, because we can recognize that it's an empty bag filled with air, where for a computer that's with that information, because it doesn't have the needed reference to kind of do that. So yeah, it's still a pattern that probably can be learned, but if we move too far away from the way that we do it, it might be actually harder to teach the computer to do something, because we have no idea how to really do that.
I was actually on a joint call with a group of people the other day, and the topic was on the whole switch to the 5G networks and what's going to happen. And some of the stuff which I hadn't looked into was the bandwidth size of what's in the latency. The latency is going to shrink to, it's a super, super tiny. It's going to be really, very, very, very almost real time, no latency. And then the bandwidth was insane. I forget how they explained it, because I wish they had done a graph or something, but they didn't. They said, like, right now you can stream, let's say, 4 movies in 4K at the max, with what we do. This is going to be like 1,400 of them or something, and it was really, I'm sorry, it was, because it still wasn't it, because their first movie wasn't in the same resolution. And I'm like, how am I supposed to compute what they just said in my head? Like, it makes no sense. But it's one of those things that dawned on me, because the distance of 5G is much shorter, as far as it's like 300 meters, if I remember right. But what was interesting, I think, with what you just also alluded to, is perhaps one of the things they can do is actually start tracking the things flying in the things in the road, debris in the road, wherever, and sharing that with the other vehicles ahead of time, so they don't even need to diagnose it. Right, it's already been done, and classify it. Right.
Yeah.
But finding ways to do that, but it is that latency speed also. It's amazing, how fast those things have to happen, the reaction times. And at some point, which I know we've talked about this, it's going to get faster than humans, right?
Yeah, for the most part, a computer will, when we start using AutoHotkey and you learn about sleep, and 1,000 milliseconds is kind of 1 second.
Yep.
And one of the things I often see people ask for is, I want to loop this hotkey and it needs to go as fast as possible. It needs to just keep clicking that L or whatever it might be as quickly as possible. And I'm like, what's the need? And it really depends on what the need is. But most of the time it's automating something or an action in a game or something like that. And what they actually want is something as quick as humanly possible, or just above. And one of the things I have had a tendency to say is a full human blink from your start to your finish, from a fully open eye back to a fully open eye, takes about 400 milliseconds, which to someone who's like 5 milliseconds between, and it's like, yeah, the computer can process it, yeah, fine, but the game or whatever you're trying to do wouldn't let you press it that quickly anyway, because it would be totally inhuman to actually expect anybody to click stuff that quickly. But yeah, for a computer, stuff are, for at least more advanced stuff than what we are doing, you might be under 1 milliseconds for stuff to happen.
And correct me if I'm wrong, but on a side conversation, we were talking about some of this, of automating things like with the Nox environment, right? Mm-hmm. And that they being the let's say a game can easily detect, usually if a human is doing stuff, because of the speed of what you're doing things, right? Of what you're doing. And it is comical. You're right. I mean, it's one of those things that with automating stuff, which is, I hadn't thought about it this way, but you're spot on, right? Of like, I have to slow my scripts down sometimes, like with web scraping, of doing something, because they go way too fast. And I don't know if it's because they built in things to stop people, stop a computer from doing it, versus just they built the website in a way that, one, it does have latency in it, right? But two is they might have built it in a way to say, hey, if it's going too fast, it's not a person, and we're going to not allow that.
Yeah, and to me, that's probably one of the things with that exact thing, is that when you think about, I learned that maybe way back, and I think they are higher now, but 24 seconds of frame for old TVs when you actually record a movie. Mm-hmm. And maybe you're up at 30 frames a second now, but to a computer, it can actually draw all of those pixels on your screen, and there's millions of them without you seeing it, and it's doing it at a hertz, at maybe 100 hertz. So maybe 100 times a second, it will actually update each and every pixel that needs to be updated on your screen to make a moving image, and it can do other things while it's doing that. It's not even hard for a GPU or whatever is handling that task, and it's just kind of put it into some kind of frame. And I think I heard at one point, when you act on instinct, I can't remember what that part of the brain that actually does that, but if you come walking down a path, it might not be greatly lit or whatever, and you're a little bit on edge, and you see something moving insecure and you don't get a really clear image of it, but it could be a bear, right?
Yeah.
And the quickest that you can actually flee from that would be after 80 milliseconds, because that's what it actually takes
Yeah.
your visual processing center to send that to that part of the brain that acts on those really, really basic things where you haven't actually seen if it's a bear, but it could also be a snake, or a branch. But
Right.
as long as it seems like it, you can act on it. But the quickest you can act on something like that would be 80 milliseconds.
Well, and that's probably for like the fastest human too, right? Because obviously different speeds.
Normally, if you ain't trained, if you just want to click something, you would use about 300 milliseconds to see it on screen and then click it with the mouse. Actually processing it, sending it to your finger and clicking the mouse would take upwards of 300 milliseconds.
Cool.
Yeah. And for a computer, that's an amazing amount of time.
You know what that reminds me of? It was one of the, I want to say older, but it wasn't the original Star Trek movies, but it was one with the Next Generation movie where Data, I forget the whole background story, but they were trying to, some computer alien tried to give him skin and then offered to give him full skin if he did this. And at the very end of the movie, Captain Picard says like, yeah, but were you tempted? And he's like, yeah, I was tempted for 0.0000049 units of a millisecond, but for me that was an eternity, right? And I'm like, yeah, it's so hard to realize like how fast computers really are.
Yeah, and of course these are the measurable things, how much we can actually process in our brain in a given time frame. That's much harder to actually narrow down, because we all know that inside our heads time is relative. So a short amount of time can take an eternity to pass, or the time can fly away, right? So
look at every one of our podcasts, right? We start talking and all of a sudden we're like, holy crap, it was supposed to be short.
Yeah, it was supposed to be short. Exactly. And I'm pretty sure we're off topic already. But
well, I did think of something to bring this back, because we both know, we do stuff in with AutoHotkey and RPA and desktop automation. It's on the left where it's not, I don't want to say simple, but it's logical of like, I do this and this and this. That doesn't mean that we can't use AutoHotkey to still do stuff on the right with stuff that would be classified normally on the right with artificial intelligence. If we just use our brains for the AI part and then, use because the AI side is doing both the analysis and the actual doing the activity, right? But there's no reason why we can't say, hey, let's still use our brains. This is one of the things I know you do a lot of the same way. I don't usually try to automate the entire thing. I want to use my brain to make a decision, have the script go do something, and then honestly, often, unless I've really done it a lot, have it let me look at it before I hit like submit or whatever, right? Depending on what I'm doing. But I really like that overall process. And so just because you're using AutoHotkey doesn't mean you can't be doing things that are much more advanced. It just means we'll let the humans do that part of it.
Yeah, and I heard at one point that at the moment we can automate processes that take up to, I can't remember, 3 minutes for a human to do. There's some kind of estimate. So what would take a human 3 minutes to learn and assess and process and then do would take us 3 minutes. That's about at where computers are. But in the same article, they ended up with this saying that, yeah, but the thing is that almost everything that we do can be broken down into so small pieces that they might only take 1 minute for a human to learn. So a computer can learn every last one of the steps if you're good enough at breaking them down and then automate that one small step. And when that's really, really tight, next one,
Right.
and so on and so forth. And what some of the bigger companies and what's really up in this time is deep learning and all of those different types of AI that's going around at the moment. And what I heard at one point was that it's giving us kind of these black boxes where we don't really know what the AI has figured out. We can see that it's doing it the way that we want it to do it,
It
but
gets the
we are not
results. Yeah.
sure why it's doing it the way that it's doing it. And I saw a TED talk at one point where someone was actually showing one of these things was a computer had learned how to recognize wolves in images, not dogs, not everything else, wolves. And it worked almost flawlessly. They weren't sure. It had just been fed with a lot of tagged images, and those where wolves were, it found out that those were wolves. And in the end, it just hit it on the head each time. That's a wolf. That's not a wolf. That's a wolf. That's not a wolf.
In a fraction of a time that a human could do it, right?
Yeah, exactly. And then it missed one. And what? Why? It was clearly not a wolf. It wasn't a hard image to actually detect that it wasn't a wolf because it was a cat. And to a human, it was so clear as day. And then they had to pick it apart and found out what's wrong. And it turned out that one of the biggest things that the computer has focused on to figure out that it was a wolf was if there was snow, white in the image.
That's
because
awesome.
Almost all of the images with wolves had a large amount of white.
Yeah, that's interesting.
And so because the cat was on a white snowy background, it ended up being tagged as a wolf. And it's just, it had worked so well.
Right.
Up to a point, and because we didn't actually know what the computer had chosen to go with.
You know what's really fascinating about that story, though? That I'll bet you money they viewed that as like a failure of going, wow, we didn't realize this was terrible. What they should have thought about was like, holy crap, all we got to do is see if there's a big white glob, right? And on average, we're right. You know, it's one of those things like if you truly only care about accuracy and not necessarily how you get there, but hey, if it's 99.9% accurate, I don't care about the logic, right? It's you know it, and they could have probably streamlined it much easier. But anyway, that's a great story.
I found it to be, to me, it was kind of an eye opener to that whole black box talk, where when we feed all of this data that we have to a computer to kind of learn and wait and all of what it wants to kind of do to get to the right point, and in the end it gets it right 99.8% of the time. And the issue is that because we don't really know why it's doing so well but not perfectly, that's probably the black box. So those 0.2% in the end are those that are really going to be hard to iron out, because we don't really know how to get them out, because we don't know what they are.
Well, and again, I just say is, what does it matter if we don't, is it really worth that extra bit of work to get it? And it depends, of course, on the circumstances and what you're doing, right? How it's going to be implemented.
Yeah, and of course with the automotive, those self-driving cars, right? Yeah. The issue is that if we are supposed to let the car drive us in every circumstance, it should really be at almost, I'm saying almost, that's just because I'm being kind. For humans to view it positively, they need to say 100% safe. It never blah blah blah, right?
Well, right.
Yeah, that's what advertisers need to be able to say to really push it, and so those 99.8 might not be good enough.
No, but and the sad part to me is that I can guarantee you, let's just pick on a subgroup of people that are over 85 years old, right? That still drive.
Yeah.
That the computer, we'd be better off having a computer with the 99.8% success rate than those people driving, right?
And that's the thing, right? Because if we can actually nail it to that degree of perfection, sure, it should just be shifted over, because you can immediately say, but on average, 10 people out of 1,000 they die, and the computer has 10 out of 100,000.
Right.
But it's the same thing each time you have an automated system. People will almost not allow it to fail at all.
Right.
Yeah.
Because you look at just the whole distracted drivers, right? Of using it doesn't matter whether it's your cell phone or eating a burger or whatever you're doing, changing the stereo. It's computers don't get distracted, so it.
Yeah, and I've seen a few of these video feeds of computers driving cars with, I think, where you have 4 data visualizations on screen, where you're kind of seeing how is it seeing with its camera, how is it seeing with its LiDAR, how is it seeing with its infrared, how is it seeing with whatever, or the 4th might actually be where it's categorizing everything. Where you actually see all of the small object boxes. That's a pedestrian, that's a car, speeds, all that information that it's kind of getting from the other 3. And it's really amazing to look at how much the car knows, computer knows, when it's driving down the street, because I might know that there are pedestrians on the sidewalk, but if there's happening stuff in traffic, it would be almost impossible for me to at the same time keep track of what the pedestrians are doing. If a pedestrian, of course, walks into the street, I would probably immediately notice it. But just the general idea of a car actually being able to see what's coming behind it, at the same time seeing what's coming from the sides, what's actually happening, determining if someone has a potential path that might cross its own and stuff like that, where we can do quite a lot dynamically, where it would be able to do quite a lot more structured. So
just to wrap it up, this was the Service Automation, Robots and the Future of Work. It was a fascinating book. I really enjoyed reading it. It had a lot of great insights on the stuff. The one that follows it, which I've read, let's see, I think it's this one. Is risk mitigation. It's a terrible name to me because it has nothing to do with what I think of risk, but it covers a lot more about when you're actually, what are the risks of using automation and choosing a software and this and that. So your solutions you're picking from.
Mm-hmm.
But that was a really good book as well. I haven't read the 3rd one yet, but I bought it. The AI. Awesome.
Yeah, well, absolutely, Joe.
All right, we'll catch you next time.
Yeah.
Bye.
Bye.